Have you ever been on a massive Wi-Fi network, maybe at a university or a huge office, and wondered how it doesn't just collapse into total digital chaos? Well, the secret is this really elegant technique called subnetting. It's all about bringing order by, you guessed it, dividing things up. Let's dive into how it all works. But before we get into the how, we really need to understand the why. Why do we even need this? And to get a grip on the problem that subnetting solves, we're going to start with a super simple analogy, a big, wide-open neighborhood. So, I want you to picture an entire town built along one single massive road. That's it. No side streets, no cul-de-sacs, nothing. Every single car, every delivery truck, every person trying to get anywhere has to use that same exact path. You can see how that would become pure chaos almost instantly, right? Well, this chaotic neighborhood is a perfect mirror for a large, undivided computer network. All that data trying to use the same path creates these huge traffic jams, just massive congestion. And when one device needs to find another, it basically has to shout at everyone. It's this noisy thing called a broadcast storm. Security? It's a nightmare because there are no walls or fences. And trying to fix a single problem is nearly impossible. It's just completely unmanageable. So how would you fix that crazy neighborhood? Simple. You'd build side streets. And in networking, we do the exact same thing. That process is called subnetting. We take one big chaotic network and we divide it into smaller, way more efficient digital side streets called subnets. Okay, so before we can start building these digital side streets, we've got to understand the blueprints for the addresses themselves. Every single IP address is basically made of two distinct parts. Just think of it like your home address. The first part, the network portion, that's like your street name. Let's say Main Street. Everybody on that street shares it. The second part, the host portion, that's your house number, like hashtag 123. It's totally unique to a specific device or house on that street. Put them together, and you've got a device's complete, unique location on the network. And that is the million-dollar question, isn't it? I mean, if you just have a string of numbers like 192.168.1.50, how does a device know where the street name ends and the house number begins? It needs some kind of divider. And that divider has a name, the Subnet Mask. Now, it looks a lot like an IP address, but its only job is to draw a line in the sand. It tells any computer, hey, listen up, this part of the address is the network, and this other part is the specific device. It's the simple little tool that makes this whole system work. Let's actually see this in action because it makes it really clear. The Subnet mask acts kind of like a stencil. Wherever you see a 255 in that mask, it tells the computer, okay, that part of the IP address right above me, that's the network. So here, 192.168.1 is our street name. And wherever you see a 0, that's the unique part, the house number, in this case, 50. That's it. That's how it knows exactly where that line is drawn. Okay, so now that we've got the foundation down, we get to the really clever part. This is where we actually create our new side streets. And the process feels a little bit like magic, and it all comes down to borrowing something called bits. Let's use a real-world example to make this stick. Imagine our company has one big network, 192.168.1.0. Our goal is to create 4 separate smaller networks, one for each department, finance, sales, IT, and HR. This way, we can keep all their traffic separate and much more secure. So how do we actually do it? Well, first we look at the host part of the address. That's the section we can play with. Now, to create 4 subnets, we need to borrow 2 bits from that host section, because 2 to the power of 2 gives us 4 unique combinations. And here is the absolute key. By borrowing those bits, we're basically making the network part of the address a tiny bit longer. This forces us to update our subnet mask to reflect that new, longer network ID. And that one simple change is what creates our 4 new, distinct side streets, our subnets. And here's the final result. Look at that. We now have 4 totally separate subnets, each with its own little block of IP addresses. The finance department's traffic stays within its network, sales traffic stays in theirs, IT in theirs, and so on. They're all still part of the bigger company network, but now they each operate in their own clean, organized digital side streets. So we went through all that work, but what did we actually gain from it? Well, the benefits are huge, and they pretty much solve every single problem we saw in our chaotic neighborhood analogy. The results are immediate. performance gets a massive boost because we've eliminated those network-wide traffic jams. Security gets way tighter. You can now create rules that prevent, say, the sales network from ever accessing the finance servers. Management becomes a breeze because if there's a problem, it's isolated to a much smaller area. And finally, you have a really organized plan for the future, for controlled growth. All right, let's do a quick recap of everything we've just covered, and then I'll leave you with a little something to think about to really make this concept stick. So, just remember, subnetting is simply the process of creating small, manageable networks out of one big one. The real magic happens by borrowing bits from the host part of an IP address, and that, in turn, creates a new, more specific subnet mask. And the payoff is absolutely worth it, a faster, more secure, and way easier to manage network. And to leave you with a final thought, just think about the networks you use every single day. At your job or your school, do you really think everyone is on one giant chaotic network? Or is it way more likely that they've used subnetting to create separate organized networks for students, staff, the library, and maybe administration? Now you know exactly why.